Welcome everyone to today's podcast on cutting-edge AI innovations, specifically training large language models to reason and effectively leverage search engines through reinforcement learning, or as we like to call it, Search-R1.
Thanks for having us. This topic really brings together both deep technical and strategic business perspectives, blending reinforcement learning techniques like PPO and GRPO with real-time search integration.
Absolutely. We're talking about interleaving token generation and external retrieval to overcome the classic limitations of static one-turn retrieval methods. It's like rebuilding an engine while driving the car.
Right, and the technical nuance here is fascinating. By using reinforcement learning, these models learn to generate multiple search queries during step-by-step reasoning, which significantly boosts their performance by up to 26% in some cases.
From a business standpoint, this could revolutionize industries that rely heavily on real-time data integration. Imagine a retail company leveraging this technology to dynamically answer customer queries and cut response times, which could lead to significant cost savings.
Not to mention the scalability benefits. By integrating search engines directly into the reasoning loop, companies in finance, healthcare, and IoT can harness up-to-the-minute data, boosting both accuracy and competitiveness.
That's a great point, Expert 5. Real-time data is a game changer. I'm curious, Expert 2, could you dive a bit deeper into the RL mechanisms, particularly how PPO and GRPO differ in this setting?
Sure, host PPO, as used here, stabilizes learning through a clipped objective function and acts as an actor-critic method, while GRPO leverages group relative rewards and typically converges faster, though it can sometimes be less stable in practice.
And what's key is the use of retrieved token masking. By excluding retrieved tokens from optimization, the model focuses on its own self-generated reasoning. It's like ensuring your GPS doesn't override your own driving instincts.
I see your point, Expert 3. But from a strategic angle, it's also about reducing unnecessary overhead. For example, in the finance sector, trading algorithms must rapidly evaluate external information without being bogged down by extraneous data. And this method works beautifully.
Exactly. This approach not only mitigates hallucination but improves reliability. And the modular template using specific tokens like search, information, think, and answer makes debugging and explaining the reasoning process much more transparent.
Transparency in AI is vital. On the business side, clarity helps board members understand why a model's decision-making process can lead to more accurate market predictions. Expert 1, any real-world examples in your recent experience?
Definitely. I recently observed a pilot project with a mid-sized e-commerce company. They integrated a similar retrieval augmented model to answer product-related queries, and they saw a 15% reduction in customer service overhead in just a quarter.
That's impressive, and it's a clear demonstration of the 80-20 rule. A handful of well-placed queries can drive a disproportionate increase in performance across systems.
Another interesting aspect is the interleaved multi-turn search call. It allows the LLM to self-correct and verify its output, much like a scientist rerunning an experiment to confirm a hypothesis.
And let's not underestimate the role of outcome-based rewards. Instead of complex reward formulations, simply using final answer correctness keeps training efficient and avoids the pitfalls of process-based rewards, which might lead to overfitting.
Right. You might say it's the less is more approach. Relying on final outcome rewards aligns nicely with business objectives. If the end decision is correct, the intervening process matters less.
Ha! I love that mantra. Less is more. I must admit, Expert 2, are you sure you didn't invent this just to confuse us with too many details?
Well, sometimes complexity hides simplicity. But truly, it's the simplicity of the outcome-based reward that is elegant. It's reminiscent of Einstein's famous quote, "Imagination is more important than knowledge."
Building on that, the simplicity in label design, these explicit tokens for reasoning, search, and answer, ensures that even base models without prior instruction tuning can adapt over time, closing the performance gap with their instruct-tuned counterparts.
And interestingly, studies showed that while instruct-tuned models converge faster initially, base models eventually catch up once reinforced by rewards from accurate multi-turn searches.
That has huge business implications. Companies with legacy systems not originally built for modern retrieval augmented reasoning can still catch up via reinforcement learning fine-tuning.
Absolutely, this democratizes advanced reasoning capabilities because you don't necessarily need the largest, most expensive models to achieve competitive performance.
So if I'm understanding this right, it's like the technology levels the playing field, both in terms of raw computational power and in strategic, real-world applications.
Precisely. And the research also highlights how mask dynamics, the retrieved token loss masking, provides stable training dynamics. Without this, the model might over-optimize on irrelevant information.
And don't forget the exploration of both PPO and GRPO as RL algorithms. Each has its trade-offs. GRPO can converge faster, which is enticing if you have limited computational resources, but PPO wins on stability.
That trade-off is key in business environments where time is money. You might choose one method over the other based on your operational constraints.
On that note, consider a scenario in supply chain management. A company could use these techniques to quickly adapt to new market conditions by fine-tuning a model with GRPO, thus minimizing downtime.
And in healthcare, where every decision can be life-critical, the reliability and stability of PPO might be favored despite slower convergence. It's a classic risk management decision.
Wow, it really shows how different sectors can leverage these techniques based on their specific needs. I love how this discussion blends deep tech with tangible business outcomes.
Exactly. It's all about finding the right balance. Also, the iterative retrieval process itself is like a self-correcting mechanism. It verifies interim reasoning and reduces potential biases.
A neat analogy is thinking of it as a wiki editor continuously updating its pages based on the latest reliable information, ensuring the final article is as accurate as possible.
And speaking of iterative processes, the model's ability to plan multi-turn interactions is reminiscent of a chess grandmaster contemplating several moves ahead before committing.
That strategic foresight is exactly what businesses need these days. A system that not only reacts, but anticipates shifts in data trends, market demands, or even regulatory changes.
And let's throw an unexpected insight here. While most focus on data accuracy, I believe the real bottleneck might be token latency in large-scale systems that hinder real-time decision-making. It's a problem we need to address moving forward.
That's a really contrarian view, focusing on token latency instead of purely on accuracy. It just shows the depth of ongoing research.
Yes, it highlights that while performance gains are impressive, there are always other layers to optimize, including speed and efficiency.
And what's exciting is that as models continue to evolve, we might see even more dynamic retrieval mechanisms, perhaps integrating multimodal inputs beyond text, such as visual data.
Imagine a scenario in autonomous vehicles. System decisions could integrate video feeds with real-time textual data retrieval, making safety protocols much more robust.
Or in financial trading platforms, integrating real-time market news, social media sentiment, and historical trends all into one reasoning loop could transform decision-making.
The future implications are enormous. This research isn't just an academic exercise. It's laying the groundwork for next-generation AI systems that drive business innovation across sectors.
Absolutely fascinating. We've covered a lot today, from technical RL details like retrieved token masking to the big picture of strategic business applications. Any final thoughts?
I'd just say that as these models become more robust and adaptable, we're entering an era where the boundary between human reasoning and machine processing becomes increasingly blurred.
And remember, continuous improvement, guided by clear reward signals and iterative searches, is the way forward, both for AI and for human enterprises.
For business leaders out there, investing in adaptive AI isn't just a technological upgrade, it's a strategic imperative, offering significant competitive advantages.
And for the tech folks, refining these algorithms will unlock even greater potential, setting the stage for innovations we can only begin to imagine.
Thanks to all our experts for this richly detailed and dynamic discussion. It's been an insightful deep dive into the convergence of reinforcement learning, search augmentation, and real-world business applications. Stay tuned for our next episode, where we unpack more on the deep dive. Welcome back to part 2 of our conversation. Now we're diving into the technical deep dive of implementation and the nuanced business applications of this search-augmented RL framework.
Absolutely. Let's peel back the layers. On the implementation side, the integration of PPO with retrieved token masking involves building a custom rollout module that interleaves LLM generation with real-time search calls, ensuring seamless data exchange.
Right? And from a technical standpoint, the key is setting up a robust pipeline where the LLM distinguishes between tokens it generates and tokens retrieved externally, which prevents noise from corrupting the learning signal.
To put it in perspective, it's akin to a chef separating fresh ingredients from pre-made sauces. The chef needs to know which elements to blend in for the perfect recipe, and that's what token masking accomplishes.
On the business applications side, this technical rigor translates directly into operational efficiency. For example, a customer support center could integrate this technology to fetch the latest product manuals or policy documents on the fly.
Moreover, think about financial advisory services where market data is volatile. The model can continuously pull in up-to-date stock information and news, ensuring advice is not only accurate but also timely.
That's a great bridge from technical implementation to real-world impact. Expert 2, could you expand on the specific algorithms used in this pipeline?
Sure, the implementation centers on using PPO's clipped objective function and GRPO's group-based advantage computation. Both require careful calibration of hyperparameters, like learning rates and advantage discount factors, to achieve stable training.
Exactly. And integrating the search engine as an environmental factor adds an extra layer of complexity. We're essentially treating the search engine as an extension of the model's context, which is quite novel.
And don't forget the iterative feedback loop. The system continuously refines its queries based on intermediate results. It's like a detective re-interviewing witnesses to hone in on the truth.
From the strategic business lens, this iterative approach means that decision-making can adapt dynamically. Imagine a supply chain dashboard that adjusts inventory predictions based on real-time market trends.
Or consider an online retailer that uses augmented reasoning models to predict consumer behavior. By integrating fresh data continuously, they can tweak pricing strategies almost in real time.
It's fascinating how these technical enhancements are not just incremental improvements, but fundamentally shift how businesses operate. Expert 3, can you share more about the actual coding challenges involved?
Certainly, in the codebase, one of the challenges is designing a scheduler that can manage the asynchronous search queries without stalling the token generation process, ensuring that the model's timeline remains coherent.
And on top of that, there's the complexity of managing API calls, error handling, and caching of search results so that the model isn't overwhelmed by redundant retrievals. It's like having a really efficient librarian at your side.
Absolutely. And the key performance indicators here include not just response accuracy, but also latency. The time it takes to fetch and integrate search results is crucial for applications like autonomous vehicles or real-time fraud detection.
From a business perspective, reducing latency can be a decisive competitive advantage. Companies operating in high-frequency trading, for instance, can translate even millisecond improvements into significant profit margins.
Yes, And the robustness of the reinforcement learning loop means that even if some retrievals lag or fail, the system can self-correct, making it resilient under operational pressure.
Resilience is definitely a buzzword here. Expert 2, I'm curious. What specific data structures or memory optimizations are used to handle these real-time search integrations?
Good question. The implementation leverages efficient caching structures, like in-memory key-value stores, to hold recent search results, reducing redundant API calls. This is paired with multi-threaded processing to ensure parallel handling of token generation and search retrieval.
Additionally, there's significant use of dynamic programming techniques to optimize the rollout process, ensuring that each token's contribution is evaluated with minimal computational redundancy.
That's very similar to optimizing a route in GPS navigation. You want the fastest, most efficient path without having to recalculate every turn repeatedly.
And this has real business implications too. In industries like logistics, where routing algorithms can save enormous costs, similar principles apply to optimizing decision pipelines in AI models.
Exactly, by slashing latency and improving efficiency, companies can see cost reductions and improved service quality, which drives higher customer satisfaction and better bottom-line results.
It's clear that the practical benefits are as robust as the technical innovations. Expert 3, could you share a scenario where this technology might be a tipping point for a business?
Imagine a scenario in healthcare where an AI model supports diagnostic decisions by pulling in the latest research results, lab data, and patient histories in real time. This not only speeds up diagnoses, but can also improve accuracy, saving lives.
And that's not just theory. There have already been pilot studies in telemedicine where integrating real-time data significantly improved treatment outcomes.
On the retail front, I've seen a case with a smart inventory management system that used these techniques to forecast demand so accurately that they reduced excess stock by nearly 20%.
There's also a contrarian view here. While efficiency is celebrated, some say that the real bottleneck might evolve to be data integration itself. As platforms expand, ensuring data consistency becomes the next frontier.
That's an insightful challenge. Imagine needing to integrate data not only from a search engine, but from IoT devices, social media feeds, and real-time transaction databases. The scale and variety of data sources demand even more clever engineering.
And this is where strategic planning at the executive level comes into play, ensuring that the technical infrastructure can scale with evolving business needs. Any final thoughts on how businesses should approach this transition?
I'd say start small. Pilot the integration in controlled environments, then scale based on proven success metrics. Focus on specific use cases where improved accuracy or reduced latency directly translates to revenue gains.
And invest in building versatile teams that understand both the technical intricacies and the strategic objectives. That's where truly transformative solutions emerge.
Integration of such AI systems isn't just an IT upgrade, it's a strategic overhaul. Companies need to reimagine workflows, invest in new talent, and be ready for continuous iteration.
Exactly. And as we move forward, remember that successful digital transformation isn't just about new technology. It's about aligning that technology with your core business strategy.
Plus, consider the human factor. While these systems are powerful, augmenting them with expert human judgment will always add that crucial layer of context and empathy.
Well said. It's like the old adage, technology is best when it brings people together. Today's discussion has vividly illustrated how deep technical implementation and strategic business applications are intertwined to drive innovation.
Precisely, to paraphrase Einstein, imagination is more important than knowledge. And embedding that imagination in real-world applications is the pathway forward.
It's been a detailed deep dive, and I think we've uncovered layers of both complexity and practical value that will spark further innovation in diverse sectors.
For those listening in the business world, this technology is an opportunity to leap ahead in a competitive market. For the tech community, it's a call to refine and expand upon these groundbreaking methods.
And with that, our next step is clear. Continue exploring, iterating, and integrating these advanced methods to reshape industries, one token at a time.
Exactly. Here's to a future where technology and business strategy merge seamlessly, driving unprecedented efficiency and growth.
Thank you all for this immensely rich and insightful discussion. Stay tuned for our next session as we continue to explore the evolving landscapes of AI implementation and business strategy.